Okay, so today we are going to go through 6L.5 of Learning the Art of Electronics, which is the inverting amplifier. So to start with, we're going to go through this circuit right there, up top. Yeah. So to start with, let's look at the formula for the gain to figure out what we'd be expecting, which is this formula here, RF, negative RF divided by RN. So RF, it's this guy here, this 10K, and then Rn is this 1K here. So that means we'd expect minus 10 of whatever we put in with the wave function generator. The reason we'd expect that is simple. Let's take an example. So assume we're applying 1 volt here. Well, now we know that this pin here must be at 0 because of our golden op-amp golden rules, and we're assuming it's a perfect op-amp. So this is 0 here, and then that means that 1 volt must be sort of burnt across here, which means 1 milliamp is traveling across here. But then we have another golden rule saying that no current flows into the inputs of an op-amp. So that means that entire milliamp is going across this 10K resistor. With me so far? Okay, good. So that means that across here, 10 volts must be dropped, which means, to get back to the this to be 0, that means that over here must be minus 10 volts. Okay, so I think that is enough explanation of the circuit here. Now, I would like to, before we go to my results on the Analog Discovery 3, to just look at the construction of this circuit in Falstad simulator. So now that's our op-amp. I chose ideal, but we will actually be using a 411, which they have. But let's just go use the ideal for now. Add a resistor at 1K. Add another resistor. Change this to 10K. We'll add a ground right there. Add a wire right here, and another wire. Just want to up there. And draw. We're gonna put a source, a voltage source. Let's just do a 1-terminal voltage source right there. Edit. We'll go with 1. Okay. So, based on what I just told you, we should be expecting minus 10 volts at this output, right? Let's see what we got. Minus 9.99. So pretty close. Okay, so I'm going to leave you here for now, and you will go and experience my Analog Discovery 3 analysis. It says to drive the amplifier with a 1 kilohertz sine wave. You can definitely do that. Then it says, is it the same? Is the gain the same as the one we just constructed? I am gonna say it is. Well, so I just want to go over a few things of this output, because I don't think I was clearly understanding stuff. So first, this is not the same as the previous circuit, which was the non-inverting amplifier that had a gain of 11. This is this has a gain of minus 10 because it is an inverting amplifier. As you can see right here, this is when we have about 200 millivolts, and then it goes up, and it's like 1.1 or 1.05, or actually no, sorry, this is the column which we are using here. That, and so it's actually 2.1 and 2.05 or 2.1 actually. 2.1 volts down to when we have 200 millivolts there. Then we go down to about minus, I don't know, 1.9 volts. So it is about a gain of minus 10. I'm sorry if I'm going to cause some confusion here with the live stuff, but let's go back to it because I do think that it is valuable just to see what I was thinking in the moment. Okay, now, that's us to add another 1K. Now, it's about half that, which is what it said, but I don't get how I'm supposed to measure the input impedance from it. Just make a note of that so we can move on. Hello. So, I just thought I'd, yeah, because I just made a note and left it, and I still am not sure how I'm supposed to measure the input impedance, but I'm guessing it would have to do with that I would measure the gain, and the gain would be slightly different than expected, and then I could sort of correlate how, like, or what is the input impedance based on how much the gain is off from my expectations. I haven't done that yet. I may later in a later video, but if anybody has any input on that, please comment, and I will look into it and hopefully learn something. Anyways, thank you for watching this video, and I hope you tune in to future videos.